Alright, we're going to take another look at finding the area of a surface of revolution. So we're going to look at the function y equals 9 minus x squared, and we're going to rotate it around the y-axis. This one's going to be a little bit different here. The radius here is going to be the distance from the axis of revolution to the graph here. So in many cases it's just the function y. In this case it's going to be it's just going to be x. So you got our surface area of surface of revolution formula: 2 pi integral a to b r of x and then square root of 1 plus y prime dx. So our radius is going to be x in this case, or our distance from the axis of revolution. So we're going to go ahead and plug that in. We're going to be integrating from 0 to 3, and then it's going to be x and then 1 plus negative 2x quantity squared dx. This is going to be just routine u substitution here. So it becomes 1 plus 4x squared dx. We'll let u equal the stuff under the square root, so 1 plus 4x squared. Du will be 8 x dx. So we're going to need to divide by 8 here. So it becomes pi over 4. And then what we can do is we can swap out the limits here. So if we plug in 0 here, then we got 1 over here, and if we plug 3 in here, we should have I think 37 as our new limits here. So it'll be 1 to 37, and then just the square root of u du. So that gives us pi over 4 times 2/3 u to the 3 halves, evaluated from 1 to 37, and that's about 117.32 in terms of that area of surface of revolution. So why we kind of look at this, because it's a little bit different than some of the other examples that you look at in terms of that r of x. It is different in this case because it's not actually the function. In class, if we have time, I'll show you that you can actually do everything as a function of y, and you can actually use this. You would have to solve our function here in terms of y. It's a pretty nasty integral, so if we have time in class, we'll go through it and take a look at that, because we can do it as a function of y. Okay.